Okay. Um, any question before we start? Um, okay. Let's start with a question. Um, how about it? This counter typically seek instant gratification, so you might expect them to be more likely to default on loans. This problem helps you to think about why it's not necessarily the case. Consider an individual who lives for 6 periods. In each period, she earns an income of $1 and she has access to two goods, samosa and empanadas. Mhm. So she has two ways to allocate her income. Either she consume samosa each day as her income arrives, or she save and consume an empanada every other day. Assume a samosa give her a utility of 1 and empanada gives her a utility of 5. Okay, so first set up the question. So we have 6 period. That's 4. Okay, so we have 6 period and each period we have $1, right? Uh, okay, so price of samosa, $1. Price of empanada equals to $2. And utility for samosa equals 1. Utility for empanada equals to 5. Okay. Hmm. Consider an exponential discounter with delta of 1. Delta equals to 1. From her period one's perspective, calculate her lifetime utility from spending her money on samosa consumption versus spending her money on empanada consumption. What will she choose to do? Okay, so this case, let's draw a table just for fun. Hmm. Okay, 1, 2, 3, 4, 5, 6. So if you consume samosa, you'll get 1 unit every single day. If you consume empanada, you will get first day you will have 0, second day you have 5 units of utility, so on and so forth. Right? So our total utility is equals to 6 and 15. So what will she do? So US is less than UE. Answer, she will choose to save for empanadas. Any question on A? Okay. Um, let's keep going with B. Consider a hyperbolic discounter with delta equals 1 and beta equals 1/2. No, 1/5. So uh, delta equals 1, beta equals 1/5. From her period 1's perspective, okay, again, it's from period 1. So I'm just going to copy this table. So from period 1's perspective, everything here is discount. Here. It's discount by beta equals to 1/5. So her total utility for US is equals to 1/5. 1 plus 1/5. 1 plus 1 plus 1. And utility for empanadas would be 0 plus 1/5. 5 plus 0 plus 5 plus 0 plus 5. So utility of samosa is 1 plus 5 over 5 equals to 2. And utility of empanadas would be 0 plus 15 out of 5, which is 3. So that's for question B. We'll choose utility alpha is greater than US, then choose this. Any question on part B? No? Okay. Everyone is super quiet today. Uh, okay, let's keep going. So for question C, event if the hyperbolic discounter prefers empanadas outcome, it's not clear she will have the incentive to actually save for them. Consider her perspective in any periods. She will need to save for empanada. Would she rather consume samosa today and tomorrow, or save for an empanada tomorrow? Okay, so um, this is a typical backward induction problem. So we should look at period 5 and 6. At what will this person do? So let's use pink. So from period 5 to 6, can draw a decision tree. So from period 5, you can either save or eat it up with 1. At period 6, you can choose. Well, I mean, you save up. So this is period 6. You save up for the money, and then you can consume total of 5 units of utility. If you don't save, at period price perspective, so for period 5, you will have either have 0 plus beta of 5 or 1 plus beta of 1, right? You have two decisions. Either you choose to save or you consume now. So what do we have? We have 1, and we have 1 plus 1/5, which is 5, 6. So this is consume, this is save. So utility at period 5 to consume is greater than utility of 5 of saving. So this person, using backward induction, we know that this person would not save during period 5 and 6. He would rather consume now than save it for later. So at period 5 to 6, this person will not follow the decision that was made from day 1. And we can take a look at period 3 to 4. So period 3 to 4 will have something similar. So we know that, so this is period 3. We can either save or consume. At this point, we can keep save. So this is 4. So this is period 3. This is period 4. Okay. Let me just ignore from period 5 and 6 for now. So let's just look at 3 and 4. So for period 3 and 4, we know that from period 5 and 6, we're gonna consume, right? So our utility from period 3 looks like this. If you consume samosa, so period 3 with samosa, with utility look like beta, well, not beta, 1 plus beta of 1 plus 1 plus 1 plus 1, 2, 3, 4, 5, 6. Okay, one more 1. Yeah. And from period 3's perspective, from saving for a banana, will look like 0 plus beta of what? Do you guys want to help me out?
Wouldn't it be like 5 plus 0 plus 5?
It will be 5 plus 1 plus 1, right? because we just used the backward induction to know that in period 5 to 6, we're not gonna follow. Right. So all that decision tree has all been cut off. Something like that. Yeah. Does that make sense? If you know
Yeah.
what to do in the future, so at this period, then you have to adjust your overall utility at period 3 according to what you were expecting your future self to do in period 5 and 6. Yeah. Okay. So what you get is 1 plus 3 fifth. And then this would be 0 plus 7 out of 5. So you'll get 8 out of 5. And then this will be 7 out of 5. Okay. Let's look at a question. What's the question exactly asking for? Even if it's not clear that your incentive to actually save for them. Consider her perspective in any period. She would need to save for an empanada. Would she rather consume samosa today and tomorrow, or save for empanada tomorrow? So we use the backward induction to confirm that in period 5 and 6, this person actually consume um, samosa rather than save for empanada. Because of this, during period 3 and 4, this person would likely to consume uh samosa again by knowing that this person is not gonna consume or it's not gonna save in the future. So yeah. So in reality, this person will actually always consume samosa. Does that make sense? Even though in day 1 that this person look at overall utility, you gain more from saving from each period, which is you will get 3 utility greater than 2 utility, right? So 3 is greater than 2. So from period 1's perspective, like you would definitely prefer to to consume empanada, like save all the like save kind of like periodically for empanada, than just consume like samosa right now. Of course, we can always go use backward induction once you find the period 3, and we know that utility 1 for samosa and utility 2, oh no, utility 1 for empanada will look like something like this. So 1 plus beta of 1 plus 1 plus 1 plus 1 plus 1. And then for empanada, you will have 0 plus beta of 5 and what? Like, what's happening here? We already know that this person in period 3 to period 6, he will consume or she will consume samosa, well, samosa, only samosa. So we just plus 1 plus 1 plus 1 plus 1. So this what you get is 1 plus 5 out of 5. This would be 0 plus 9 out of 5, right? So in reality, by using backward induction, we know that pair 1 for samosa would be 2. Yeah. So this would be 1 and 5 or 4. So this is a reality. The reality. This is more preferable outcome, right? Okay. Any question on C? Um, am I talking too fast or is everyone uh am I explaining this thing clear?
Yeah, it makes sense.
Okay. Okay, that's great. Okay. So we know that oh okay. We know that this person will not will actually consume samosa all the way because he's inconsistent. So in this case, if you have a commitment device, uh, and maybe that will work, right? If you have some sort of commitment device, then you can actually get this ultimate better outcome. Okay, let's go D. So now, suppose a nonprofit Bank of E, shows up and help individual to consume empanadas. This bank offer loans for $1 in period 1, 3, and 5. Each loan must be repaid the following period. No interest is charged. So if the individual borrow $1 in any period, she gets to combine that with her income and consume an empanada that day. But the next day, she has to use her income to repay the loan. So she cannot consume anything. From the period one's perspective, calculate the exponential discounted lifetime utility of entering a borrowing relationship with a bank. Do the same for hyperbolic discounter. Okay, so we have to do two. One is exponential and one is hyperbolic. So how do we start with exponential? Okay, so exponential would be u is equals to 1 and then delta plus delta of 1 plus delta square of 1 plus delta cube of 1 plus delta something like that, right? For exponential. So you will get U equals to 6. If you're only eating samosa. Oh, well, samosa. Okay, let's actually bring back the table again. It's easier with the table. Okay, so this is no bank. Bank. And this is bank. If it's bank, you can borrow it right now and consume the empanada. It'll be 5. And then you pay back at period 2. So on and so forth. Okay, so what happened to period 6?
They have to spend that period repaying back as well, don't they?
Right, that's well, imagine the world doesn't end at period 6, right? But if the world is ending at period 6, if the world ends at period 6, you will have this. You'll eat the samosa in the last day. You will not pay back to the bank. Right. If only 6 period. But yeah, anyway, but we don't have a default option yet. So we have to follow this no bank rule. So we will have 5 plus beta of 0 plus 5 plus 0 plus 5 plus 0. We'll have end of the utility. Oh, sorry, guys. I'm supposed to calculate for exponential. Okay, let's keep with our exponential. So exponential utility for exponential with empanada will look like 5 plus 0 plus 5 plus 0 plus 5 plus 0. Right. Because this one is greater than eating samosa. So as an exponential discounter, you will always stick with borrowing money and pay it back. Let's do hyperbolic. Okay, now your hyperbolic discounter, what would you have? You have a utility. We already know that hyperbolic discounter would prefer eating consume empanada. So you will have 5 plus beta 0 plus 5 plus 0 plus 5 plus 0. So u is equals to 5 plus 2 equals to 7. Okay, so let's ignore this default position right now. It's important for E. But for D, yeah, this is what you should have for hyperbolic. Because you can borrow it early 1 period that actually boosts your utility way above, well, way more than the original hyperbolic. So what's the beta coefficient again in this case?
1/5.
What's beta coefficient?
1/5, right?
No, yeah, 1/5, but like, what does it represent? Like the intuition of beta?
Just like any future gets discounted because it's in the future.
Right. Yeah. So like, because this person it's like have a really low beta. Low beta means that he has a very high discount in the future, right? So if he can consume now, he will rather consume now. Yeah. Okay. That's good. Okay. So any question on D? Okay, let's go into E. Again, assume the bank can enforce repayment on the period 3 and period 5 loans, but it cannot enforce repayment on the period 1 loan. Because that point, it still doesn't know the consumer well, so it come up with the following rules. If the consumer default in period 2, then she will not get next 2 loans. Now, consider an exponential discounter who took a loan in period 1. In period 2, she's trying to decide whether to repay the loan. From period 2's perspective, she must compare her lifetime utility of repaying versus defaulting. Will she choose to repay? Okay, so from period 2, right? So period 1, you already consume an apanada. So let me see if I can draw a table again. One. So from period 1, you already consume apanada. So yeah, you have 5 utility. And now you're in period 2. You can choose to repay, which is 0, or you can choose to not repay, and you have a 0, and this you can save into the future. Or you can default, but consume now with Samantha. Well, Samantha? Eating Samantha. Samosa. Right. Okay. So from period 2, let's draw a decision tree. You can either default or not default. What's the utility function looks like if this person default?
From period 2 perspective,
Yep, period 2.
would it just be that they just use 1 for the rest of the time?
He can choose to either do 1 or you can choose to do save, right? So if he save, so if he does 1, then he will have plus beta of 1 plus 1 plus 1 plus 1. If he save, he will have beta of 5 plus 0 plus 5 plus 0. Right? But will this person commit to do this? If he is hyperbolic. No, because we use the backward deduction. We use the backward induction. We know that this person is definitely not going to save during period 5 and 6. And then there's no way this person will save. So this one is out. So the only thing we can have is this. If this person default. So if not default, what will happen? What's the utility look like? Oh, I'm not reading the question right. This says only exponential discounter. Yeah. And then we only do the hyperbolic discounter on question F. Okay. Let's keep going with the exponential discounter. We'll come back with an exponential discounter. So what happened if on period 2 exponential, well, no, hyperbolic discounter didn't default? What's the utility look like for not default?
In period 2, they'll have a utility of 0 because they repay.
Okay. Mm-hmm.
And then in period 3, they get the loan, so they'll have a utility of 5. And then 0 for the next. And then 5, 0. Yeah.
Yeah. Yep, exactly. Right. So it will have a utility of 2. Oh no, 2. Right? Am I crazy? I'm not crazy, right? Yeah, it's 2. So Is it though? What if I default in the last day? So if you're an exponential discounter, so you have to kind of like, oh, I have to use backward induction to see if the default day is actually the last day or if the default day is actually the first day. Well, not when I say first day, it's period 2. Right. Because during period 5 and 6, we have to make a decision. So period 5, period 6, we can choose to borrow and consume 5 units, right? Or we can consume or we can choose to not borrow, which you only have 1 unit, and then you will have 1 unit here. So if you pay back in period 6, it will be 0. If you don't, you can consume extra samasa in period 6. If you default in period 6. This is the default. So in period 5, U5 is equals to 5 plus beta of either 0 or 5 plus beta of 1. So clearly, at period 5, this person will choose to default in period 6. What about period 4 and 3 and 4? What can happen? The things I'm talking about only like this question specifically, but you should probably prepare that in event of delta is not equals to 1, right? So if delta is not equals to 1, if this person is exponential, well, I mean hyperbolic with some exponential discount, this person can have a drastically different preference in when to default. Right? Because for now, I'm just like plugging numbers because I'm just ignoring the delta. But in the exam, there might be delta, right? So we need to consider if delta is in our model. So period 3 and 4, we can save. And then if we default on period 4, we'll have 1, right? So if we save, then period 4, if we don't default, it's 0. And then there's another option of eating samosa all the time. Samosa. So you can choose to not borrow, and then you will have a 1. So utility of 3, for period 3, you will have 5 plus beta of if you default plus. We already know that if defaults, this person will never save. So we can just keep going. Period 3, 4, 5, 6. That's it. Period 3, if it doesn't default, will look like this. But we know that this person, if it doesn't default, it will default on the last day. So we compare their utility. We have 5 plus 3 out of 5. And we have 5 plus 6 out of 5. So this person would not choose to default at period 4. No default. And then we can go back to period 2 again. So how do I do period 2? We already did. It's right here. And this is what we are actually going to do in period 2. It will default in the last day. Okay, so that's for the hyperbolic. And exponential is easier because our delta equals 1. Compare 2. Default. Not default. So what will you have for default if you're exponential discounter? Plus 1 plus 1 plus 1 plus 1. This one it's only eating the Samantha. And if you're eating a banana, would be 0 plus 5 plus 0 plus 5 plus 1. Oh. Oh, no. No one is giving you money at the last period because you already default. So no one is willing to give you money anymore. So all your consumption is let me see. So if you're exponential, you prefer to save, right? Okay. So if it's exponential, it will save. So in period 2, the exponential will be different because in period 1, he already saved. So if he save, he saved, he can consume right now, and then he posits 0 plus 5 plus 0 plus 5. Oh no, plus 0. So yeah, okay, this is correct. This is correct for not default. For not default. Is it for default or not default? Doesn't matter. Because there's no delta equals 1. Delta equals 1, it doesn't matter. Because your utility will be the same. Right. This is the elongated series of if you borrow. So if there's a bank. And then 0 plus 5 plus 0 plus 5 plus 0 plus 5. This is if not, if there's not a bank. No bank. Right? The exponential discounter already save in period 1. He's definitely gonna save. Like he don't care, but because his delta is equals to 1, he doesn't care about, like he doesn't discount like future items. So for exponential discount, it doesn't matter. He's indifferent about whether or not there's a bank or not, because it will be the same utility and exponential discounter will follow through. But in period 2, can exponential discounter default and gain the system? So if they default, they will have. So they borrow the money in the previous period, and then at this moment, they're giving $1 more. If they were giving $1 more, they can choose to not consume. So if they choose to consume, so top, it's if they choose to consume. Oh, never mind. They'll have 1 more extra utility. Oh, so exponential discounter will actually default. Yeah, they will default. 5 plus 10 plus 1, 16. Yeah, 16 is greater than 15. Yeah, exponential discounter will default. Okay. Any question on E? D or E? Yeah, E. Yeah, I'm looking at the solution now. So this is period 1. This whole thing is period 1. So period 1 go away. So yeah, this person will likely to default because he can get 1 more utility from defaulting. Am I confusing? I feel like I'm confusing. I'm confusing myself. Okay. So let's see if I can draw it again. Okay. Just this is so not useful. So P2. The default. Not default. So if you default, you'll get, you can save or not save, right? So if you save, it's 0 plus, so that's pure 2. 0 plus 5 plus 0 plus 5 plus 0. But if you consume, if you default and consume, you can have 1 plus 0 plus 5 plus 0 plus 5. But if you don't default, you have 0 plus 5 plus 0 plus 5 plus 0, I guess. But we said it's like gonna default. Then there's no difference between this and this. Okay, I'm confusing myself. Sorry.
Andrew, I have a question.
Hmm.
So the only time like you would like the possibility of only consuming the samosas would be for the like if the hyperbolic discounter defaults, and like the reasons because we did it through backward induction, but like for all the other like cases like the um like there is a possibility that they could save for the empanada.
So for exponential, they will always choose to have a apanada, right? Because their delta equals to 1. And for hyperbolic, we use the backward induction. Yeah. Yes. Yes. But also, I feel like I did something wrong. Oh, 1 second. Let me just read the question one more time. Okay, so for the exponential, yeah, the exponential would choose to default in the last state too. Oh, okay. This is super confusing. 。 Yeah, both cases leads to that the hyper or the exponential will always default. Will always default. According to when will exponential discounter will default, it depends on the delta. If delta equals to 1, the exponential discounter would be indifferent to default at any period. So this is what we get for question E. Let me just double check. Am I answering question D already? Oh. Yeah, we did D, and then we're doing E. The bank can enforce repayment on period 3 and period 5 loans. Okay. I missed this. So if the bank can enforce the payment, so then therefore exponential discounter they can't default in the last period because the bank can enforce repayment. So that will be 0. So yeah, exponential will still default, but in period 1. Sorry. Didn't read the question careful enough. Okay, does that make sense for E? Okay, let's redo the hyperbolic since we can't really default in the last day. See what can we get for our hyperbolic. Okay, so we have hyperbolic. This is F. Hyperbolic. Beta equals to 1/5. Equals 1. Default. Or not. Okay, what would be the default scenario be? If default, we know that this person can consume one unit of samosa in period 2, right? And we already know that this person will always choose samosa. Yeah, always choose samosa. So we'll have 1 plus 4/5 if this person or hyperbolic default. If not default, let's see what will hyperbolic discounter do. If not default, it's 0. In this case, the bank can still enforce the repayment in the last 2 period. So the hyperbolic will actually follow through with 2. Okay, sorry about all the confusion. Okay. Yeah, okay, that's it for E. E and F. Any question on this? Ah. Okay, if not, if there's no question on this, G, yeah, G is just explain the intuition on how the bank can become some sort of, I guess in this case, enforce the hyperbolic to follow through with their plan in a way. Because the first period would be 5 plus 0 plus beta of 5 plus 0 plus 5 plus 0. Well, this beta should be here. So this whole thing. Is that the case though? Yep. It is the case. Because the bank will enforce the payment. Okay. So kind of want to like briefly talk about like number 4. I saw a lot of people did question 4 wrong. So assignment 5, question 4. You have a utility of this individual, right? So you have a yt minus half yt minus 1 minus h to the t square. And we know that y is equals to hour. And we have a y0 is equals to 0. If you live through 2 periods, so you have 0, 1, and 2, and you have no discount in the future. So A. If she anticipate the impact of her current consumption on the future utility, how many hours will she work in each period? Solve each period separately. Keep in mind that period 1's decision affects period 2 as well. So let's do period 1. So how do we set up this question? So we're trying to max H1 of U1 plus U2. So we'll have max of H1 of Y1 minus half 0 minus H1 to square plus Y2 minus half Y1 minus H2. So you have D, U, DH1. You'll get, this should be H1, H2. So you have 1 minus 2H1 plus h1 plus -1/2 equals 0. So you're supposed to get 1/2 minus 2h1 equals 0. Set them equal. h1 equals 1/4. So if you want to do the period 2 separately, you just have to max h2. And utility equals to the sum of all the utility. But we know that in period 1, we don't care about period 2. So in this case, we only have h2 minus 1/2 h1 minus h2, 2. So du dh2 is equals to 1 minus 2h2. 2h2 equals 1, h2 equals 1. Okay. So that's question 4. I see a lot of people got it wrong, so I just want to, yeah, bring it up. Okay. Concerns with previous assignments or difficulties? Okay.
On the final, do you think the like question 2, is it gonna be? Sorry, 1 second. Is it gonna be more like where it was the responder sends triple back, or is it gonna be just like the ultimatum game?
You should remember both games. Right.
Okay.
And also try to have the intuition on the mental accounting as well. Because the mental accounting actually appears on, well, the year before me.
Oh, really? Okay.
So yeah, try to at least have the intuition on the mental accounting.
Yeah. Okay.
How does it work, and why is it important? And give
Okay.
it. And I think today there's a student that was asking about why taking the derivative. Where is that question again? Why are you taking the derivatives on the thing to find the beta? Oh, found it.
So sorry, in the review video that you posted, did you go over the Fair-Schmidt model from last year's final, or?
Yeah, I did.
All right, thank you.
So yeah, this is like from question 2 on last year's final on why, like, how to find the max of t. So you take the derivative with respect to t, and then you can find the beta from that. So how can maybe should we like go over C again?
Yeah, that'd be nice.
Okay. Let me see if I can pull up the question. For example. Okay. Okay, so for B, for C, okay, C. For now, let's assume S is large enough that responder will seriously consider how much to send back. She must choose T to maximize his utility. So write out the utility maximization problem fully, but don't resolve it yet. Okay, so yesterday we talked about this whole sending money back and forth kind of scenario. I'm just gonna copy this and then we can look at it again. So this is what we have yesterday. So proposer can give some S amount of money to R to responder, and then responder can give some amount of T as a return, right? So because both party has a Fair-Schmidt model or Fair-Schmidt of like inequality, that they do not like inequality, right? So under what circumstance will R send any amount of T to P? Under what circumstance?
They'll send it if like 3S is bigger than 1 minus S.
Right. So the amount of money that you send it to me, and then when the money was like transmitting through this like magical device, I got triple, right? So the money I have right now, when it's triple, it must equal to the amount of money that you have right now, right? So this is a proposal. Proposer's money. It's money right now. So this is a responder's money right now. So if our amount of money is equal, according to what we conclude on the Fair-Schmidt model, if our money is equal, then what happened? In this case, if you have $100, I have $100, why the hell I'm sending money to you, right? Unless I have more money. If I have 101, okay, maybe I will start and you have a $99 or some sort or whatever, but you have less money than me. So then I will feel pity and then I will send you some money, right? Some amount of T. So this is the condition we must obtain to have responder to send any amount of T. To proposer. Right? Okay. Now, where are we? Okay, we need to write out the utility maximization problem fully, but don't solve yet. So what's my utility again? If under the condition that I have to send some amount of T to the proposer. as a responder's utility at this point. So max T. And what's the utility? Beta of what? Because now I have more money than you, right? So I have to send you some amount of money. So it's 3s minus T minus 1 minus S plus T. Right? I remember it correctly. Yeah. So this is how you maximize your utility by sending some amount of T. It's under the condition that you actually gain utility from sending T.
Wait, I'm sorry, why is it 1 minus S plus T?
Because this is a proposer, right?
Right.
But if I'm sending amount of T, you get some amount of T. Right?
Okay, I see. Okay, thanks.
Okay, so under what beta will I be happy to send as much T to you as possible to maximize my utility? This is what this maximization was doing, right? So under what beta will I be able to happy to send you all the maximum amount of T? Okay, so when we solve this question, du dt, we get negative T. So kind of like symbolize this, so put them together. So minus minus plus 4s minus 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 2t minus 1. So minus T minus beta of 2. Right? And then set them equal to 0. So negative 2 beta equals to T.
I'm sorry, Andrew, can you repeat why we're including the proposer's income?
I'm sorry. What
Are
do
we
you say?
including the proposer's income? Actually, wait, never mind. Sorry, I think I figured it out. Sorry.
Mm, I'm kind of confused on my own maximization. Give me 1 second. It should be a whole number. No. What am I doing? Sorry. My brain's not working. I can't even take the derivative anymore. Jesus Christ. Oh, I'm final on Tuesday. Okay. So this minus minus it's plus. So plus 2 beta. So beta equals 1/2. Okay. Gee. Okay. So does this make sense? Like this whole maximizing problem? Like why do we maximizing T? This is du dt. A unit change of u and unit change of t. Okay, so how do we interpret this beta? Just intuitively. So if our beta is greater than 1/2, what will happen? If we have beta less than 1/2, what will happen?
When beta is above 1/2, then you get more utility from less inequality. Then when beta is below 1/2, you would send like the least amount possible.
Right. Exactly. So on yesterday, I think I give this three explanation. Not this. Where is it? I'm just like so out. This is 1, 2. Here. Take the derivative. Okay. So if beta is greater than 1/2, this is the only point where utility maximized by giving any amount of t, in which responder will have increased utility in increasing in t. So the more I give it to you, the more I feel happy. Or the less pain I will suffer from this beta thing, right? If I have beta more than 1/2. So this is the 3 condition. If beta of a responder is greater than 1/2, they gain the utility from giving any amount of t, right? The more amount of t I give it to you, the more, well, yeah, in that case, I will be maximize my utility. So if the responder is, the beta of the responder is equals to 1/2, the responder's utility is unaffected by amount of t. So I'm indifferent whether or not I give you any money or not, right? But Jesus, okay, you get it. But if it's less than half, responder don't feel guilty of inequality. So it will be likely to give in 0. Giving you like nothing in return. Right. This is the 3 scenario that we come up yesterday. Because this is a very different than the automaton game. This is a trust game. Okay. If you want to like go over the question 2 fully, the video is up. I think I explained pretty detailed yesterday. Yeah, so use that. And you have your homework assignment 5 grade up already, so you know where you get wrong, and then make sure you just read the answer key as much as you can. And try to go over all the games that Professor Basu talk about in class, such as like the trust game and ultimatum games. Yeah. Try to be comfortable with multiple period utility maximization problem too. Because that will appear to the yeah, that might appear on the exam. And definitely mental accounting. Since you guys have the homework for mental accounting. Last year, I didn't have a mental accounting. In the exam, there's no mental accounting. Like we don't have a mental accounting problem because of like a very scattered schedule. So it was like taking off like completely. But you guys have more. Well, more in terms of like other area of stuff. Is Basu's exam cumulative? Is that what happened?
Yeah, it is.
Okay. Yeah, then you should kind of
Well,
go the
What homework was mental accounting?
assignment 5.
Oh,
Assignment 5, let me see. Assignment 5. Yeah, this question?
so the first question was mental accounting. Okay.
Yeah.